Okay, so what did we talk about yesterday? What was yesterday all about? Yesterday was about, listen carefully, or statements. If there's ever an or, like probability of this or that, okay, then you want to check, is there a chance that there's an overlap? Is there a chance that both, that I'm double counting? Okay, so that's hint number one. Hint number two is if you have a question like this where it gives you the percentage of one thing happening, the percentage of the other thing, and then maybe the percentage of both happening or neither. You're thinking, hey, this looks like a Venn diagram, right? This, that, neither, or both. Then that's another hint. You want to make sure. Oftentimes students, I recommend go for a Venn diagram right away. And then you know, right, when you fill that in, you can answer according to that. So let's go to page 30. Okay. Newspaper claims that 62% of students skip breakfast, 24% of students skip lunch, and 22% eat both. I don't like this question a lot. I don't like it at all, actually. But I think it's good to get your brains to think. Like, wording is what I'm trying to address here. The wording is kind of tricky. Are these events mutually exclusive? Okay. Let's do a little bit of, let's try to do our Venn diagram here before we answer that. So we've got skip breakfast. That's 62%. Skip lunch. That's 24%. And if it's percentage, what's my universal? It is 100%. Okay. So skip breakfast, skip lunch. What would you do with a 22 eat both? I'm trying to test you here. Eat both, 22. Would you put that in here? Because Mr. Dirksen, it says eat both. But they're eating, they're not skipping, right? So in this case, the ones that eat both are the outliers. I don't like this question. I'm telling you up front, like I still like, I'm guiding you through it. But in this case, these are my outliers. They don't skip, okay? All right, so if we were to add up, this is always my check, add up 62, 24, and 22, is it gonna be exactly 100% or is it gonna surpass it? So let's do a check. 62 plus 24 plus 22 and what do we get there? We get 108, right? Therefore, events are non-mutually exclusive. Okay, events are non-mutually exclusive because there's an overlap, they're joint. Okay, so you could use pi. I think in this case we know it's 8% is going to be the overlap, but I'm going to use pi here. Pi in this case for probability is 100 minus 22. Then we go 62 plus 24 plus x, which is the overlap. This is 78. This gives me 86 plus x. Oh, I'm making a mistake, right? It needs to be minus x, my bad, right? We subtract the overlap. And in this case, we go minus 86 to both sides. we end up with -8 and -x like that. We divide both sides by -1. So 8% skip both. That's what you just found. Once you know that, we can go ahead and insert that. 8% goes here. 62 minus 8 is 54. 24 minus 8 is 16. And now you've got a full Venn diagram. Now we can answer things properly. Did it ever ask you for a Venn diagram? It didn't, but I would strongly recommend when it's cases like these, I would do it. Find the probability that a student skips breakfast but not lunch. And again, it says probability of skipping breakfast but not lunch. That would be, in our case, 54%. They're only skipping breakfast. For C, determine the probability of a student getting neither breakfast nor lunch. What is it asking for? Is this, so what, if it's getting neither breakfast nor lunch, it's basically skipping breakfast or lunch. That's basically what it's asking. So it's the union of these sets here, right? So this is probability of B union lunch. So that's 54 plus 8 plus 16. How else could we have done this? Union, you go universal minus outliers, right? That would have been another way of doing that. So that's 78%. Okay. Let's go to page 32. When there's dice, make an outcome table. When there's coins being tossed, I would make a tree diagram, like especially if it's more than 2. Okay, here, on page 32, question 5, what's the probability of drawing a red queen or, that's plus, right, a face card? State the odds of that happening as well. If there's or, you need to check. So red queen, you've got 4 queens, right? At home, I only have 1 queen, but a deck of cards. 4 queens and a face card. If you think of the face cards, there's 12, right? 12 altogether. So we're basically, like, if you want, I like colors, because when I study, then I go over it, and I'm like, oh, okay, I see what you're saying. Face cards are the 12 here. And then red queen, there's only 2 reds, right? Like 2 are red, 2 are black. So there it is. When you have something selected and something else selected within it, you are going to be double counting if you just go ahead and add them, right? You are going to double count. So probability of red queen plus probability of face, right, minus probability of both. So red queen, there's 2 out of 52. So this is a little deceiving because, oh, there's only 12, Mr. Dirksen. No, this is like zooming in. The deck of cards, I'm zooming into the ones I care about. So there's 52 options. Face cards, there's 12 out of 52. minus, I'm going to subtract the instances where I've already double counted them. I've already counted them in my face card. Like when I counted the face cards, I've already taken care of these, right? So these basically cancel out if you want to look at it that way. So you end up with 12 out of 52. And if you reduce that, that's 3 over 13. Reduced. If you want odds in favor, I'm going to just make sure I state that I'm doing odds in favor here. In favor of a red queen or a face card. You use your probability. That's all you have to go off of right now. So I would go 3, 2, 13 minus 3. When you go from probability to odds, you need to subtract at some point. So it's 3 to 10. What if I said odds against? Don't go back to your probability. Just use this. If you have 4, then just flip it. And then you've got the odds against. Next. The probability of drawing a red face card, a red ace and a black card. Or is you got to add those two scenarios. And I want to say one more thing here. Let's just step back, overview. Why is this not perms or comps or anything like that? Because I'm only considering drawing one at a time. Okay, so I'm not making groups of 5, hands of 5, a hand of 4, a hand of 3. I'm not doing that. I'm just grabbing one at a time. So the probability of drawing a red ace, there's 2 red aces, right, out of 52. Black cards, there are 26 out of 52. Do I need to subtract anything? Is there an overlap? Are there any red face cards that are also black cards? No. 0 out of 52. Okay, these are disjoint. If the province ever asks you for disjoint sets, okay, odds and even, red and black cards, those are classic. Rolling dice and rolling an even or an odd, there's no overlap. Okay, rolling even and multiples of 3. You don't have to copy this, but even would be what? 2, 4, 6, right? And multiples of 3 would be 3, 6. Oop, there's an overlap, right? So you need to subtract that. You need to subtract the 1 overlap there. Okay. I think that's it for now, unless you have any pressing questions here. Summary of mutually exclusive events. What are mutually exclusive events in a short term is disjoint sets. That's what they are. On a Venn diagram, there's no overlap. Okay? There's a lot of different ways of talking about mutually exclusive. Events are mutually exclusive if they cannot happen at the same time. Okay? Or they just cannot happen. You can't have both. Okay? An event diagram, the sets would not overlap or be disjoint. Check if events are mutually exclusive by adding the elements in the set, including outliers or intersections, to see if they add up to the universal. 100% if percentages are provided. Okay? So here we go. Tell me, go through this list real quick and tell me whether go ME or non-ME. Just tell me that, like from A to F. If you go through that list, could you tell me? All right. So the question is always, is there a chance that they could both happen at the same time? That's the question you want to ask. Could they happen? Could they both happen? That's basically what you should ask. Could they both happen? Rolling a number divisible by 2. If it's divisible by 2, and we're assuming it's a six-sided die, right? That would be 2, 4, 6. Divisible by 3, it would be 3, 6. Right? So in this case, you can clearly tell there's an overlap. So this would be not mutually exclusive. Rolling a number divisible by 2 or a multiple of 5. Divisible by 2, 2, 4, 6 again. Multiple of 5, it's just 5, right? Like you can't do, the next one would be 10, which is not an option. So these are mutually exclusive, no overlap. They're not sharing an element. Think of disjoint sets, like these two sets do not share elements, okay? Drawing a red card or drawing a king. Okay, there are 13 red cards. These are non-mutually exclusive because a king can also be red. Done. Okay. Drawing a black card or a diamond. What are diamonds? Diamonds are all red. Okay. Hearts and diamonds are red. Okay, my diamond does not look like a diamond. There we go. Okay, and then there's the clubs or spades. They're black. So, is there a black card that can be a diamond? No. So these are mutually exclusive. No, all diamonds, we can just say this, all diamonds are red. Or you can say no black card is also a diamond. You can say it that way. Varun being late or Dilraj being late. What do you think? Is there a chance that they're both late? So these are not mutually exclusive. They could both be it raining or being sunny on a particular day. Not mutually exclusive. It could rain and be sunny on the same day. There you go. So sometimes it's just using words. Sometimes you can actually make your Venn diagram. So there's several ways of doing that. Okay.